I think for so many of us, that image of the pillars of creation, well, it's probably the first thing you picture when someone says nebula, maybe on a poster or, yeah, a screensaver back in the day.
Oh, absolutely. It's iconic for a reason, just visually stunning.
Mhm.
But what we see as this sort of majestic monument is actually just one small, very active corner of space.
Right. So today we're diving into that. It's part of the Eagle Nebula M16, which is, what, about 7,000 light years away out in Serpens.
That's the one. And yeah, our mission today is really to dig into what these things are, like what they're made of, why we call them pillars of creation, and this ongoing drama about whether they're actually being destroyed as we watch.
Okay, so structurally, they're sometimes called elephant trunks, which is quite a picture. More technically, cold molecular pillars.
Exactly. Think of them as these enormous columns, mainly cool hydrogen gas and dust. They really do look like giant stalagmites stretching upwards.
And the scale is just mind-boggling. The tallest one, isn't it something like 4 light years long?
Yeah.
Just that one pillar.
Yeah, 4 light years. It's truly massive, a huge spire of gas.
So why pillars of creation? It implies something's being born there.
Well, that's precisely it. They are stellar nurseries. Inside these dense columns, new stars are actively forming. That's the creation part.
But hang on, you also mentioned destruction. There's intense radiation, right? From nearby stars. How do baby stars even survive that?
That's the paradox, isn't it? You've got these incredibly powerful, hot young stars, nearby O and B types, blasting the pillars with ultraviolet light. It's a process called photoevaporation, basically boiling the pillars away.
So how do the new stars form? It sounds like they'd get vaporized before they even ignite.
It comes down to these really dense knots of gas inside the pillars. Astronomers call them EGs, evaporating gaseous globules. Kind of a fun acronym.
EGGs. Okay, so they're like little cocoons.
Exactly. These EDGs are dense enough to shield the material behind them, creating these shadowed columns, the pillars themselves. Inside that protected zone, a protostar has a chance to gather mass and, eventually ignite.
Wow. So the pillars exist because they're being destroyed. The EGGs cast shadows, basically.
Precisely. The very process, carving them out and making them glow so spectacularly, is the erosion caused by that UV light hitting the surface gas.
It's like trying to make sense of creation and destruction happening all at once on this huge scale. It's complex.
It really is. Sorting through all that data from different instruments, different wavelengths, it takes work to pull out the real story.
That process of navigating complexity, finding the signal in the noise, it applies to so many things, not just astronomy. Which actually brings us to our sponsor for this deep dive, Embersilk.
Yeah.
If you're dealing with complex information, maybe in your business, or trying to figure out automation, Embersilk can help. They specialize in AI training, integration, software development, basically helping you figure out where intelligent agents could make a real difference. So if that sounds useful, check them out at embersilk.com.
Right. So back to the pillars and that idea of destruction. There was a pretty big stir, maybe 20 years ago, from the Spitzer Space Telescope data.
Yeah, I remember that. Didn't it suggest there was all this hot dust, maybe from a supernova that had already gone off?
That was the theory. They saw infrared signs of hot dust and calculated a supernova might have exploded maybe 8,000 or 9,000 years ago.
And since the pillars are 7,000 light years off, the idea was the shockwave would hit them, or maybe already had hit them, and we just wouldn't see it for another 1,000 years, like they were already cosmic ghosts.
Exactly. A really dramatic picture. But more recent observations have kind of changed that view.
With Hubble's newer images in 2014, and especially JWST, right? The Webb telescope.
Absolutely. JWST, looking in the near infrared, can actually peer through a lot of that dust that blocks visible light. And what it sees? Well, it tells a different story.
Not a sudden wipeout, but more like slow erosion.
Pretty much. It confirms that photoevaporation, that steady boiling away by the nearby stars, is the main driver. The pillars are definitely shrinking, but the estimates now suggest they've probably got at least another, say, 100,000 years left, maybe more.
So not ghosts just yet. And having these different views is key, isn't it? Hubble sees the surface in visible light.
Right. Then you've got Chandra looking in X-rays, which picks up those hot young stars outside the pillars, the ones doing the damage.
And Webb sees into the pillars, spotting baby stars actually forming, even seeing the jets of material they shoot out as they're born.
Yeah. It's incredible. You put it all together, visible, X-ray, infrared, and you get this dynamic picture of creation, erosion, survival, all happening right now across those 4 light years.
That's just so.
So for you listening, what's the takeaway from this amazing structure?
I think for me, the really profound thing to chew on is how the beauty we see, the very light that forms that iconic image, that light is also the force that's slowly dismantling the pillars.
Creation and destruction hand in hand. It's a fundamental cosmic dance, isn't it?
Definitely makes you think. Well, if you enjoyed this deep dive into the pillars of creation, please do subscribe to the show.
Yeah, and hey, if you have a moment, maybe leave us a 5-star review. It genuinely helps other curious minds find us.
It really does. Thanks so much for tuning in.